Okay, right. So we have this question here. It says in the figure, O is the center of circle ABCD, and DB is equals to DF. AODF, BOE, BCF are straight lines. CFD is equals to 10 degrees. Right. So now what we want to do is we want to analyze the diagram first, right? We want to extract all the data from the diagram before we even attempt to solve the questions. So we have this equal sides, so this here is 10 degrees, meaning also here it's 10 degrees, right? And then if we have 10 and 10 here, it can follow that D3 here is equals to 160 degrees. Now let's look at Dr. CPT. We want to see if we have any diameter. We've been given here BOE, and then we can see that it passes through the center. So any line that goes from circumference to circumference passing through the center is a diameter. Now what we want to check is that diameter subtending a 90-degree angle there. So if we can check here, this is a diameter, and BOE is a diameter, but also again AOD is a diameter. So where do we have 90 degrees? We have 90 degree here, and then we also have a 90 degree here. If we take that also AOD is a diameter, so also here we have 90-degree angle, right? Then let's check if we have any radius. So the radii are this. So AO is radii, BO is radii, OE is radii, and OD is radii. Now we know with this ones, if we have radii, we know that the angles here and the angle here will be equal, and also here the angle here and the angle here will be equal, right? And then we want to check if we have any chords. So do we have any angle subtended on the same segment? If you look at this, let's hold chord BD. If we hold chord BD, we can see that BD subtends an angle at A, but also BD subtends an angle at E. So that follows that A here is equals to E, right? And then let's hold arc AE. We can see that arc AE subtends an angle B1, and then also it subtends another angle D1. So we can say that B1 and D1 will be equal. Then if you can just check here, O2 and O4 vertically opposite angles, and then your O1 and O3, they're also vertically opposite angles. If you check them like this, your O1 plus O2 angles on a straight line, and then your O2 and your O3 angles on a straight line, your O3 and O4 angles on a straight line again, and then the whole of this revolution angle, right? So we were just playing along with the diagram. Now let's try to answer the questions. Here it says calculate D2. So if we look at D2 here, we can see that D2 is here, and then if you can check the relationship of D2 and the whole of this triangle here, you can see that D2 is an exterior angle of this triangle, right? So we know that an exterior angle of a triangle is equal to 2 opposite interior. So that means D2 is equal to 10 plus 10, which is 20 degrees. And then the reason is exterior angle of triangle, right? Now let's look at A. So here is A, and then remember we have D2, this is 20 degrees, but then here we have 90 degrees. If we can look at triangle ABD, we can see that the interior angles of a triangle must be equal to 180 degrees. We have 20, we have 90, that's 110. So here that means we have 70 degrees, and our reason is sum of interior angles of triangle, right? And And what about O2? Now, where is O2? We have our O2 here. If we can see, O2 is an angle at the center. Let's see if we have any theorem relating to the center. So if we can hold chord BD, we can see that chord BD subtends an angle at the center, which is O2. But then chord BD also again subtends an angle here on A, which is on the circumference. So angle at the center subtended by BD, and another angle at the circumference subtended by BD. Angle at center is twice angle at the circumference, so O2 must be equal to 140 degrees. Reason is angle at center is equal to 2 times angle at circumference, right? Then let's get to C1. So where is C1? C1 is here, right? But then let's check C1 with A here. If you can check A, B, C, D, A, B, C, D, you can see that this is a cyclic quad. All the vertices touch the circumference, right? So this is a cyclic quad. Now we know opposite angles of a cyclic quad, they are supplementary. So A is 70, that means C1 must be 110 degrees. So we say here opposite angles of cyclic quad. So opposite angles of cyclic quad. Then what about E? So where is E? E is here. And then remember we said if we hold chord BD, BD subtends an angle A, and also BD subtends another angle E, right? So we can see that A and E are angles on the same segment. So E again must be 70 degrees. And then here we say angles on same segment, right? Then what about C2? With C2 we can see that already here we have C1, which is 110 degrees. Then C1 and C2 are angles on a straight line, so they must form 180 degrees, meaning C2 is equals to 70 degrees. So we say 70 degrees, and then angles on a straight line. Also again we can see that C2 here is an exterior angle of this cyclic quad, so C2 must be equal to the opposite interior, which is A. A is also 70 degrees, so that one is also acceptable. And then what about O3? With O3 here we can see that if we have O2 and O3, they are angles on a straight line. So what is O2? We have calculated O2 to be 140 degrees. So what number can we add to 140 to give us 180? That's 40 degrees. So O3 is 40 degrees. And again here we say angles on a straight line, right? And that's how you go about with this question. Ra